Hello everyone, I am Neelam Choudhary, your host for the web series Django Project Based Learning. So, before we jump into today's topic, do me a favor. Give that like button a tap, and if you haven't subscribed yet, hit that subscribe button. Alright, let's get started with today's topic. So, today we'll see the timetable generator with the help of the Python and Django, and the algorithm that I have used for this particular project is a genetic algorithm. So this is how your project will look like. We have a register and login functionality. So once you log in, these are the different tabs you can see over here. And when you will click on generate timetable, it will generate the timetable for you guys. So this is how it will generate the timetable. So if you need the source code of this project, you can write a mail to codingumbrella@gmail.com and I will provide you the source code at a very minimal rate. If you want more such kind of projects, you can go to the playlist that is Django Project Based Learning. So over here you will see many such projects, and also you can study the basics of Django before creating the project. So let us start with today's topic, timetable generator. So over here, I will not be creating the project from the scratch as it would take a lot of time. So what I will be doing, the project is already been created. I will be explaining you about the algorithm and the models and the files how I have created. I will explain the source code in detail. Okay. So let's start with today's topic. We have created a project, University Classroom Timetable Scheduler. So the assumptions are each teacher can teach multiple courses, and the constraints are the sitting capacity of the room must be greater than or equal to the number of students in a class. It will also ensure that the classes for the same sections, they do not overlap in the class timings, and the different class which are scheduled at the same time, they do not share the same room and the professor. The optimization objectives that is used in the algorithm is to maximize the utilization of classroom throughout the week, minimize the gaps between the classes, to distribute the classes evenly across the days and times. Now let us see the implementation of this project. So let us run the server. So here you can see this is a directory structure of the project. Let us first see the project before going through the code. So this is how the projects look like. We have the register and login functionality over here. Help section will basically help you, anyone who is going to use this project will help them to understand how we can generate the timetable. So let us log in. Provide the password. And you can click on login. Maybe wrong password I have entered. Let me again enter correct password. So this is how the website will look like after you have entered the correct password. So here you can add the professors. You can delete the professors as well. You can add the rooms. You can delete the rooms. You can add the timings, the time slots, and the days of the week has been provided. You can delete the timings as well. You can add the courses. Since one course can have multiple professors, you can select the professors as well, and then you can delete also. Then departments, you can add the departments as well. One department can have multiple courses. You can select multiple courses. You can delete the department. Then you can add the sections and you can delete that particular sections. And when you will click on generate timetable, it will generate the timetable based on the number of professors, rooms, timings, courses and departments you have created for that particular sections. Okay. It will take about less than 1 minute to create this particular timetable. So now the generation is 62. By the time it reaches 200 generation, okay, you will get the output. So you can see the timetable has been generated. While generating this timetable, all the optimization criteria has been met. That is maximizing the classroom utilizations, minimizing the gaps between the classes, and to distribute the classes evenly across days and time. So for every sections, you can see the timetable is generated, and also the maximum utilization of the classroom is achieved. And also we had made sure that the classes with the same course within the same sections will have the same classroom. So the learners don't have to keep on changing the classrooms, okay? And also the time has been distributed evenly. So now let us see the code for this particular project. So before understanding the code, let us understand about the algorithm on which it is based upon. It is based on the genetic algorithm, which is an optimization algorithm. First, it will generate the initial population, which is nothing but a population of possible solutions, potential solutions. Then it will go through the evaluation phase. First is a fitness calculation, where each solution in the population will be evaluated using the fitness function and will check how well the solution solves a given problem. Then what we'll do, then we'll see whether it is meeting the stopping criteria or not. If it is not meeting, it will go through the selection phase. In the selection phase, the solutions are selected from the current population to serve as a parent for the next generation. And the probability of the selection is based upon the fitness function. And the method that we have used is a tournament selection. Then if there is a crossover applied for this population. So what happened? A pair of parent solutions are selected and a crossover operation is applied to that to generate a new offsprings. Then the mutation happens. So in mutation, what happens? Some random changes are applied to the offspring solutions. So we get some more diversity in our population. Then generate the next population. So the new offspring solutions along with some of the existing solution from the previous generation will form the population of the next generation. And now again the algorithm will repeat the process for the predefined number of generation or until the termination condition is met. Now let us see the code. So now let us see the structure of our code. This account is an application related to the authentication and authorization. This is a project which have another application, timetables, where we are going to generate the timetable. So let us see the models first. So here we have defined the time slots and the days of the week. There is a room model which has a room number and the sitting capacity. We have professor model which have the ID and the name. Class time which have ID, time and day. Now it may happen the user may select the same time and date again. So to avoid this, we have written this particular code. Then we have courses which have course number, name, maximum number of students and professor. Since one course can have multiple professors, we have many to many fill with the professor model. Then we have department which has department name and the courses. Since one course can have one department can have multiple courses, we have many to many fill with the course model. This is basically to get the courses. We have created this property which will return the courses over here. Then sections will create the sections. We have ID, department, number of classes in a week, courses, class time, room and professor. And all these parameters are related to one or the other wardens using the foreign key concept. This is basically to set the room, to set the class timing and the professor for that particular class. Now let us see this file. So the maximum generation is set to 200. Maximum generation is set to 200. The population size is set to 4. Number of elite schedules, which are nothing but the top performing schedules that are preserved without undergoing the crossover or the mutation in each generation. Then the tournament selection size is 2. It means that in each tournament, 2 schedules or the individuals will be selected randomly for the crossover and the mutation. And the mutation rate is set to 0.02. So we have this. We have this class data, which is nothing but a utility class, which will provide the access to various data objects. So we'll fetch the data from the databases and we can access that particular instances with the help of these functions. Then we have a schedule class, which is nothing but a representation of the schedules, and it holds various informations like the number of classes in the list, a number of classes, all the classes in the form of a list, number of conflicts, fitness change, and this is basically to keep the track of the used room. Then it has various functions in it. Get classes is basically it will change the fitness value and it will return the list of the classes. And this function will give you the number of conflicts. This function will basically calculate the fitness only if the fitness value has changed. Otherwise, it will not calculate the fitness value again. So basically, it is used to it is preventing the redundant calculation and improving your overall code efficiency. Then we have initialize method. So this is basically is responsible for populating the class list with the instance of the classes, and it is to generate a set of the classes for each sections considering the constraints like the class number of classes per week, available class timings, the professors and the rooms. So over here first we are fetching all the sections from the database, all the available rooms and the class timings. We are sorting the class timing over here. And for each section in a sections, like we can have multiple sections. If I first we'll take the first section, A. Okay, we'll find out the department of that section and the number of classes in a week. Then depending upon the number of classes, if it is equal to the length of the meeting timing, what we'll do, for that sections, we can have multiple courses. So we'll take first course over here. For the first course, we'll first assign the professor and we'll make sure that we'll first assign the classroom. And we will make sure the same classroom is allocated for the same course. Okay. And then what we will do, then we'll create an instance for the class. And for that class, we'll set the class timing, which will find out sequentially. Then we'll set the room time, which we'll get it from here. Then we'll set the professor randomly. Now in the genetic algorithm, whenever we generate a population, whenever we have diversity, we get more optimal solutions. That is why I have gone for the mixed approach where the classrooms and the class timings I am taking sequentially, but the professors I am taking randomly. So we have the diversity in our population. And then that instance, we are appending it to the classes. So one class has been created. Now, if the number of classes per week is 12 and the length of the meeting timing, the timings that we have is only 10, so it will make the number of classes equal to the meeting timing, and the same approach will be followed that we have followed in the earlier section of the code. So calculate fitness will calculate the fitness of that individual. Initially, the number of conflicts we will keep it 0. Now for each class, what we'll see, if the classroom capacity is less than the maximum number of students, it cannot hold that many students, it will increase the conflict by 1. And if both the classes, then we'll compare the class I with one class with the another class. And if they have the same timing, and if they have the same room and the same professor, again, it will increase the conflicts by 1. So this is how we are calculating the fitness in our genetic algorithm. Then we have a population. So population class is basically responsible for managing a population of schedules. And each schedule is instance of class schedule. And we can access that particular schedules with the help of this particular class. Then we have this class dot underscore schedule, which is nothing but an instance variable. It is a list comprehension that create a list of the schedules, and each schedule instance is initialized using the initialize method. Okay. So in genetic algorithm, we have evolve method, which will perform the crossover on the population and then the mutation. So in the crossover population, what we are doing, we are performing the crossover on the population to create a new population with a mix of the schedules from the current population. And the top performing schedule, that is a number, that is elite schedules, they are passed directly to the next generation. And from the remaining schedule, we are selecting the 2 parent schedules with the help of the tournament selection. And then the new offsprings are created using the crossover schedule method. And the new schedules are added to the crossover population. In the mutate population, what we are doing, So this method basically it performs a mutation to the population, excluding the elite schedules. And then we have crossover schedule. So over here, what we are doing, we are performing the crossover between two schedules to create a new schedule. And for each class in the schedule, it is randomly selected from either of the parent based on the probability threshold of zero point 0.5. And then the resulting schedule is a combination of the classes from the two parent schedules. Then we have a muted schedule. So in the muted schedule, what we are doing, okay, so it will apply the mutation to a schedule, altering some of its classes. For each class in the schedule, there is a probability mutation rate that we have taken that will be replaced by the class from a new schedule. Then we have a tournament selection, basically it is to choose the schedules for the class over. We will randomly select the schedules from the current population to participate in the tournament, and one with the highest fitness will be selected. The process is repeated until the desired number of schedules for the crossover is selected. So for us, how many we are going to select? For 2 times. Okay. Then we have a class named class. So this class basically does what? So it represents a class in the scheduling algorithm, or it holds the information such as the section ID, department, course, professor, class time, room, and the sections for that particular class. And we can get that particular section ID and department of that class with the help of these functions that we have created. Then, so context manager is basically used to create a context for the given schedule. So over here, first we get the list of the classes from the schedule. Okay. And in the context, which is initially empty list we are creating, then we'll iterate through each class in the schedule. We'll iterate through each class in a schedule. First, we'll create a dictionary to store the informations about the classes. And then in this dictionary, we'll populate the information, okay, about the class ID, class department, courses, rooms, professors, and the class timing. And then what we'll do, then we'll add this class information to the dictionary, and then we'll return the final context list, okay. Then we have a timetable. In the timetable, what we are doing, and first we have created our list schedule, which is used to store the final class schedule. Then we are creating an initial population of schedules. Then we are setting the generation number to 0. And then we are sorting the schedules in the initial population based on the fitness value. And then we are creating the instance of the genetic algorithm. And then we are checking for the criteria. If the criteria is met, it will stop the loop. Otherwise, it will continue the evolving the population until the maximum number of generation is met, or if the top schedule in the population reaches a perfect fitness of 1. Okay. So over here, if it is not met, it will increase the generation number by 1. This is just to print, okay, to see which generation and what is the fitness value of that particular generation. Then what we are doing, we will evolve the population using the genetic algorithm, and then again we'll sort the schedules in the population based on the fitness value. And then what we are doing, we are updating the schedule variable with the classes of the top schedule in the current population. And this loop will go on till the criteria is met. Then it will do what? It will render the template timetable.html file with the schedule sections and the timings. Okay. And then we can see the output. So basically, whenever we are clicking on generate timetable, this function is called, and this function is calling the every other functions or the classes of this particular code that we have written. Okay. So the remaining of the code is basically, it is to define the index.html page. Okay, it is for the help page. And this is for the professors. The code is for adding the professor, for editing the professor, and for deleting the professor. The same 3 functions are created for the rooms, for the timings, for the courses and departments and the sections. Okay. So this is a code. I hope this is clear. I hope you have liked today's project or timetable generator. If you need a source code, kindly write a mail to codingumbrella@gmail.com, and I will provide you at a very minimal rate. Okay. The rate at which you eat a burger in KFC. Okay. So now, if you want many more such videos, kindly like and subscribe my channel, and also go and watch the playlist that I have created on Django project based learning. Bye bye. I will be coming with the next video very soon.